Have you ever hit send on a message and just stopped and wondered, how does that actually work? How does your data zip across the entire planet in literally the blink of an eye? Well, today we're going to pull back the curtain on that incredible, invisible journey. I mean, really think about it for a second. You tap your screen and say New York, and your friend in Tokyo sees that photo almost instantly. It feels like magic, right? But it's not magic. It's some of the most amazing engineering on the planet. And it all starts with one simple idea. The secret behind all of this is the computer network. And that sounds complicated, but it's not. It's simply a system that lets a bunch of different devices talk to each other. Your laptop, your printer, your smart TV, and servers thousands of miles away, they're all just part of a network. Now, to get our heads around this giant global system, we have to start small, really small. We're going to start right inside your own home, because that's where the first leg of your photos journey begins. This is your home turf. It's called a local area network, or LAN for short. You can think of it like a private little club for all the devices that are physically close to each other. Your phone, your computer, your game console. They're all hanging out, chatting on the same local network. So who's directing all this local traffic? That's a little device called a switch. The best analogy is an internal mailroom in a big office building. The switch knows exactly which desk or which device each piece of mail needs to go to, and it delivers it right there. But, and this is the key, it only handles mail inside that one building. So how does the switch know where to send everything? It uses something called a MAC address. The easiest way to think about it is that your device's MAC address is like its fingerprint, or a permanent serial number. It answers the question, "Who are you?" on the local network. This is completely different from another address we're about to meet, which answers the question, "Where are you?" in the big wide world. Of course, you're not plugging a cable into your phone anymore, right? You're using Wi-Fi. Well, your wireless access point, or your Wi-Fi router, basically acts as a wireless switch. Its job is just to get your photo off your phone and onto that local area network. No messy cables required. Okay, so our photo is on the local network. It's in the building. But its final destination is on the other side of the planet. So how does it get out the front door and onto the open road? That brings us to the next stage of the journey. This is the job for a router. If the switch is the internal office mailroom, the router is the main city post office. Its entire purpose in life is to connect different networks to each other. It takes the data from your private little LAN and sends it out toward the vast global network. And that global network has a name, a wide area network, or WAN. The internet is just the biggest, most famous WAN there is, a mind-bogglingly huge web of interconnected networks that spans the entire planet. This is the ocean our little photo now has to cross. And to navigate this giant ocean, your data needs that second type of address I mentioned, an IP address. This isn't about who the device is anymore. It's about where it is in the world. Routers all over the globe look at this IP address to figure out the next best hop for the data on its long journey to the right destination. Okay, so we've sorted out the hardware. We have switches for local traffic and routers for global traffic. But what about the photo itself? How does it actually travel? This is where things get really, really clever. Here's the thing that blows most people's minds. Your photo doesn't travel as one big file. No way. Trying to send a huge file all at once would be like trying to shove a cruise ship down a garden hose. It would just clog up the whole system for everyone. So the network does something much smarter. It uses a method called packet switching. Your beautiful high-resolution photo gets chopped up into hundreds, maybe even thousands, of tiny little pieces called packets. Each one of those packets is then sent out onto the internet all by itself. And now for the really wild part. Just like cars driving across a country, each one of those packets can take a completely different route to get to the same destination. One tiny piece of your photo might zip through London, while another goes through Tokyo. The network is constantly finding the most efficient path for every single packet at that exact moment, avoiding digital traffic jams along the way. Okay, so hold on. We've got thousands of tiny packets of data zipping all over the globe, taking different routes. That sounds like absolute chaos. How does any of it ever get put back together? The answer is that every single device on the network has agreed to follow a very strict set of rules. For any of this to work, everything has to speak the same language. All the devices need a shared agreement on how data gets packaged up, how it's addressed, and how to make sure it's received properly. This universal understanding is what holds the entire internet together. In the world of networking, this shared language is called a protocol, and the foundational rulebook for the entire internet is called TCP/IP. You can tell by the name, it's really two key protocols that work together like a perfect team. And here's how they split the work. The IP part, Internet Protocol, is the addressing system. Its only job is to stamp the destination IP address on every single packet. It's like writing the address on an envelope. Then you have TCP, Transmission Control Protocol. TCP is the reliability manager. It numbers every single packet, 1, 2, 3, 4, so they can be put back in the right order at the end. It also checks to make sure they all arrived safely. If one is missing, TCP asks for it to be sent again. So we've got the hardware, we understand the packet switching method, and we know the rules of the road. Now let's put it all together and watch our photo complete its incredible journey from start to finish. So let's trace it one last time. First, your phone breaks the photo into tiny, numbered TCP/IP packets. Second, those packets travel wirelessly to your local router. Third, your router sends them out onto the great big internet. Fourth, the packets scatter, racing across the globe on countless different paths. Fifth, at the destination, TCP acts like a puzzle master, gathering all the packets and reassembling them in the correct order. And finally, step 6, the photo appears on your friend's screen, perfectly intact, all in less than a second. It is an absolutely incredible system of organized chaos that we rely on every single day, an intricate dance of hardware and software that connects billions of us. And it leaves us with one final thought. As our world gets more and more connected, what's the next great challenge in keeping this global marvel running smoothly and securely for everyone?